Hi, here's a run through of some gas law problems that you might see on the test on Wednesday. The first one is 3.25 liters of a gas at standard temperature and pressure is compressed to 473 milliliters and heated to 70 degrees Celsius. What's the new pressure of the gas? Check with this one. Two of them is that you need to know what standard temperature and pressure are. So you take your 3.25 liters. Standard pressure is 1 atm. Standard temperature is 273. And then this has to match. So if this is in milliliters and this one is in liters, you make them the same. You can't just plug them in. So convert it to liters by dividing by 1,000. So 0.473 liters. And we're looking for a new pressure of the gas. And the new temperature is 70 plus 273, so 343 Kelvin. So to set up for the first one, if you cross multiply and divide, P2 is equal to 8.63 atmospheres. You could have had it in a few other things as well. You could have done this in kPa if you wanted to. Then it would have been like, I don't know, close to 1,000 kPa. Car has an internal volume. So number two, car has an internal volume of 2,100 liters. The sun heats the car from temperature to 30 to 65. What's the pressure inside the car? Assume volume is constant, so this number is not really necessary. If volume is constant, that means you don't need to use that variable. So you just have P1 over T1. So that would be 755 millimeters of mercury over 303 Kelvin. And then you're solving for P2. What's the new pressure? New temperature was 338 Kelvin. So cross multiply and divide, and P2 equals 842.2, and that would be millimeters of mercury. Number three. You have an unknown quantity of gas, a pressure of 1.5 atmospheres, and a volume of 35 liters, a temperature of 47. How many moles of gas do I have? So if it says moles, that's your indication that you're going to use the ideal gas law. If you want to rearrange it and solve for moles, N equals PV over RT. And the pressure in this problem is 1.5 atmospheres. The volume is 35 liters. The R for atmospheres is 0.0821. And the temperature is 320 Kelvin. So for the first question, the answer would be 2 moles if you calculate that. If the gas is carbon dioxide, you would take your 2 moles of CO2 and you would multiply by the molar mass of CO2, which is 44. Set up like that. And then 2 times 44, of course, is 88 grams of CO2. In number 4, you're giving grams first, so you're going to use the ideal gas law also, but you want to convert your grams to moles before you can plug it in. You're solving for temperature. Temperature equals PV over NR. To use that, though, you got to find the number of moles. So take your 49 grams of Cl2, chlorine's a sneaky 7, don't forget that. And the molar mass is 71 grams per mole on bottom, so it cancels out. That equals 0.69 moles. That's the same for N for the ideal gas law. Now you can plug it directly in. So you got 4.4 atmospheres. The volume is 120 liters. Number of moles we just found is 0.69. And the R for atmospheres is 0.0821. So all that math gets you a really high temperature, 9,318.6 Kelvin. Number 5 is a gas at a pressure of 74 kPa and a temperature of 55. Heat an additional 230 degrees. What's the new pressure going to be? The additional is the key word there. So we're not using temperature, or sorry, we're not using volume. So that one means you don't need to use that variable. So it's just P1 over T1 equals P2 over T2. So when you plug them in, the first pressure is 74. The first temperature is 55, which plus 273 is 328 Kelvin. Then it goes up an additional 230 degrees, so you actually add 230 to this number. So it's not like it goes up from 55 to 230. It's this number plus 230. So that's 558 Kelvin. Solve for the second pressure, and P2, if you cross multiply and divide, equals 125.89 kPa. Number 6, you've got 3.9 liters of a gas at a pressure of 6 atmospheres. This one looks like it's a combined gas law problem. So it's 3.9 liters and 6 atmospheres. The initial temperature is 331 Kelvin. And the other one is that it goes to 1.4 liters now, and that 4 atmospheres of pressure. And the new temperature, if you cross multiply and divide, the second temperature is 79.21 Kelvin. On the quiz, you'll also have a question like this one where you've got an equation that's already been balanced for you, and you want to use it's a gas stoichiometry question. So in this problem, we're given volume. So you start with the ideal gas law and you solve for moles. And then you're going to take those moles and convert them to mass of magnesium. In this problem, we're starting here at oxygen and we're going to end at magnesium. So number of moles of oxygen, PV over RT. The pressure is 0.67 atmospheres. The volume is got to be in liters, so 2.17 liters. The R is 0.0821. And the temperature here is 85 plus 273 for 358 Kelvin. That gets you to 0.0495 moles of O2. But now you can take that and you can use stoichiometry to get over to magnesium. So it's a 1-to-2 ratio. 1 oxygen gives or reacts with 2 magnesium, and the molar mass of magnesium is 24.3 grams. So if you take this number times 2 times 24.3, you'll end up with 2.4 grams of magnesium. So there is a run through of optional practice test for the gas laws test, which happens on Wednesday. Bye, losers!